welcome to my channel. In today's video, I'll discuss about three matrix operations. Number one, matrix addition. Number two, scalar multiplication. And number three, matrix subtraction. Before I start with the topic, let us see answers of the exercises given in the previous video. If you haven't seen that video, link is given in the description. So the answer of first question is A is equals to 2, B is equals to 4, C is equals to 3. And for the second one, there are two solutions. There are two answers. P is equals to 4, Q is equals to 2, R is equals to 0, and P is equals to 2, Q is equals to 4, R is equals to 0. Since you get a quadratic equation in this problem number 2. And answer for the third one is W is equals to 5 by 4, X is equals to 9 by 4, Y is equals to 5 by 2, and Z is equals to 11 by 2. I hope you all must have got the right answer. And if you have any query, if you want me to solve any of this problem, let me know in the comment section. I'll surely add the solution in my upcoming video. Let's start with the topic. So let's start with the first topic, addition of matrices. Let's see the definition. If A is equals to Aij and B is equals to Bij are two matrices of same order. I have taken general order m by n. Then the sum of the two matrices A and B is obtained by adding corresponding elements of both the matrices. Nothing but here we are talking about component wise addition. We also call it as component wise addition. Nothing but element with the same index will be added. Here you can see the first element of A plus B is A11 plus B11. Nothing but element with the index 11 gets added with element with the index 11. Similarly for all the elements. Nothing but you have to add the element component wise. And one very important thing over here, A plus B is defined only if both the matrices are of same order. You can't add two matrices with two different orders. If you have different order matrices, A plus B is not defined. This is very general example I have taken. I have taken one small matrix of order 2 by 3 to explain the same thing, and I have used your GIF image to explain the addition of matrices. I hope you like the concept. Do comment in the comment section if you like the GIF image and if you like the concept used to explain the via GIF image, so that I can use the similar type of GIF image to explain few more concepts. So what I have done in this, I have taken two matrices of order 2 by 3, and you all can see the first element of A plus B is A11 plus B11. Nothing but the first element of A, that is A11, gets added with B11. Then second element is A12 plus B12, that is A12 gets added to B12. Nothing but you all can see the element with same index gets added. 2 2 added with 2 2, 2 3 added with 2 3, 2 1 added with 2 1, like that. I hope the idea is clear. I'll show you the GIF image again. do let me know the idea of using GIF image to explain the concept. If you liked it, or if you didn't like it, then also let me know. Let's see some example. For the first example, again I have used the GIF image. Let's see. Okay. So in this example, you all can see to explain this concept, I use two things. One is the color combination and second is the GIF image. So I have a red color element 2 and red color element 5, which gets added 2 plus 5 to give you 7. Then I have a yellow color element 3. Then I have a yellow color element 6 at the same position, which gets added to give you 3 plus 6, that is 9. Then light green color element, that's 0. With the same position, light green element 4, 0 plus 4, that's 4. And like that, your A plus B is done. Let's see another example. So here are two matrices, and I'll suggest you pause the video and do this A plus B. Here is the answer. I hope you all must have got the same answer. Let's go to the next. Next, we are going to see multiplication of a matrix by a scalar. Nothing but in short, we call it as scalar multiplication. What are we going to do in this one? We are going to multiply a matrix by a scalar. Scalar, nothing but a number. Number can be a real number or a complex number. Let's see how to do that. Here is the definition. If A is equals to Aij, a general matrix of order m by n, and K is a scalar, then the scalar multiplication of K by A is obtained by multiplying each element of A by K. Nothing but Ka is equals to K into Aij. The new matrix which you will get after scalar multiplication is nothing but obtained by multiplying each element of A by K. Easy? So what you need to do here, you have to multiply each element of A by K to get the scalar multiple of A. Let's see the same thing with a smaller matrix of order 2 by 3 in a GIF image. So I have a matrix of order 2 by 3 over here, and I have taken one scalar quantity K, and I'm going to evaluate this K into A. I'm going to perform this scalar multiplication over here. How to perform scalar multiplication? How to multiply a matrix by a scalar quantity K? We need to multiply each element of A by K. The first element was A11, so that you have to multiply by K to give you K times A11. Similarly, you have to do with rest all. A12 multiplied by K A12, A13 multiplied by K A13, and like that for other elements also. It's easy. I'll show you the GIF image again. Okay, so let's see the example. So I have a matrix of order 2 by 3 and I am computing here 3A. I'm multiplying matrix A by scalar quantity 3. Nothing but a number 3. How to get this 3A? You have to multiply each element of A by 3. So you can do, it's done step by step over here. The first element is 2 multiplied by 3. 3 into 2, that's 6. Second element is minus 1 multiplied by 3. 3 into minus 1 is minus 3. Third element is 0 multiplied by 3. 3 into 0 is 0. Fourth element is 4. 3 multiplied by 4. 3 fours are 12. And like that, 3 into 7 is 21. 3 into minus 6 is minus 18. I hope the idea is clear. What you need to do to perform a scalar multiplication, you have to multiply each element of the matrix by that scalar quantity, by that number. Let's say another example. Here is your matrix A, and I have to multiply this matrix A by minus 2 this time. So I'll suggest you pause the video and get the answer. Here is the answer. Let's go to the next. Here is my matrix A, and now I want this minus 1 into A. This example is very important. I'll suggest everybody pause the video and compute the same. Here is the answer. I hope you all must have got the right answer. One few things I'm going to note over here. The scalar multiplication which you are performing here, this minus 1 into A, can be written as minus A, because in usual mathematics, whenever we say, this minus 1 into x, so we never write this minus 1 into x like this. We write it as minus of x. This minus 1 into, let's say, 2. So we never write it like this, minus 1 into 2. We write it like minus 2. So here we use the same thing. This minus 1 into A is that minus A, and we call this matrix as negative of A. This is very important thing over here. This minus A matrix which you have got, this minus A matrix which you have got is known as negative of A. Negative of A. And practically what we do to get negative of A, we just change the sign of each element. Nothing but 2. If we change the sign, that will become minus 2. Minus 1, if we change the sign, will become 1. 0, 0 is a neutral element, so sign doesn't change. There is no change in sign. There is no sign actually, so it remains 0. 4 becomes minus 4. 7 becomes minus 7. Minus 6 becomes 6. This example is very important, I'm telling you, because we are going to use this in further topics. What we call this? We call this as negative of A. This minus A is called as negative of matrix A. Let's go further. So here is your next operation, subtraction of matrices. And actually speaking, this is not a new operation. This is a combination of the previous two operations. What was the previous two operation? Matrix addition and scalar multiplication. This we combine to define subtraction of matrices. Let's see the definition. So we have to take two matrices of same order. I have taken two matrices of same order m by n. Then the subtraction of the two matrices A and B is defined as A minus B is defined as A plus minus of B. So nothing but what I wants to say, to get A minus B, what we do, we get this minus b first. Minus b is what? Negative of b. We just now saw one example. So to get a minus b, what we do? We do this minus b first, nothing but we get negative of matrix b. And what we do? After that, we add matrix A with this negative of matrix B. So what we have done actually, we have done this scalar multiplication first. This is nothing but scalar multiplication. And then we are doing this addition. That's your matrix addition. So your matrix subtraction is nothing new. It's not a new operation. It is actually composition of the two operations. Composition of scalar multiplication and matrix addition. But in practical use, we don't use this concept to get a minus b. What we do to get a minus b practically, we just simply go for component wise subtraction. The way we used to do addition, the similar way we do the subtraction. So we do it this way practically. We go for this component wise subtraction of elements. Nothing but element with same index will be subtracted. A11 minus B11, A12 minus B12, A13 minus B13. Like that, you have to subtract. So I have told you two things over here. How A minus B is defined. That's the first thing I told you. And second thing, how to do it practically. Let's say example. So here is example. I have two matrix A and B. I'll suggest you to pause the video and get A minus B. So here is the answer. I hope you all must have got the right answer. What you need to do here, you need to do component wise subtraction. The way you used to add, same way you have to subtract. First element is 5, you have to subtract 1 from that. So 5 minus 1 is 4. Second element is 7, you have to subtract minus 4 from that. 7 minus of minus 4, so will be added and that will give you 11. 0 minus 6, 0 minus 6, minus 6. Minus 2 minus 3, minus 2 minus 3, minus 5. 1 minus 2, 1 minus 2, minus 1. Minus 3 minus 7, minus 3 minus 7, minus 10. I hope the idea is clear. So next we are going to see the properties. So first we will see properties of matrix addition. So one important note over here, all the matrices are considered here are of same order and I have fixed that order to m by n. Here is your property number 1, commutative law of matrix addition. Commutative law is a plus b is equals to b plus a. What do you understand by this? We understand the order doesn't matter over here. Whether we add a to b or we add b to a doesn't matter. Whether we perform a plus b or we perform b plus a doesn't matter. Okay. The second property, associative law. If you concentrate on the left side of this, I have a plus b in a bracket plus c. What it means? A plus b will be performed first and whatever you'll get that will be added to c. And let's come to the right hand side. In right hand side you can see b plus c in a bracket. So b plus c will be performed first and whatever you'll get that will be added to a. and there is a equality in between. So that means LHS equals to RHS. And what do you understand by this? We understand order does not matter. If we have more than two terms and we are talking about addition of matrices, order does not matter. In which order we are performing the addition. Whether we are adding the first two terms, then we are adding to the third term, or we are adding second and third term first, and then we are adding to the first term. This is very important property. Here is the third important property, existence of 0. A plus 0 is equals to 0 plus A is equals to A. The 0 which you see here, this one, this 0 which you see here is not a real number 0. That's a null matrix. Very important thing to note over here. That's a null matrix of order m by n. A is matrix of order m by n. So 0 is also a null matrix of order m by n. What do you understand by this? If we have a matrix and that's added to a null matrix, then you get the same matrix. There is no effect on the matrix A. That is also one of the important property. Let's see the next property, existence of additive inverse. A plus minus of A is equals to minus of A plus A is equals to 0. This minus of A which you see here, that you know that is a negative of matrix A. And what is the benefit of this? If you add a matrix with its negative, you will get 0. And this 0 is again not a real number 0. This 0 is nothing but null matrix of order m by n. So if you add a matrix with its negative, that will give you 0, a null matrix. That we understand by this property. Let's see next. So next you are going to see properties of scalar multiplication. Property number 1, k times a plus b is equals to k times a plus k times b. Here k is a scalar, a and b are matrices of order m by n. So what is happening here? The scalar k is distributing over matrix addition. This k is distributing over addition of matrix. You can see this k multiplies with the first matrix to give you Ka. This k multiplies with the second matrix, that's B, to give you Kb, and here is your matrix addition. So what we have here, we have scalar distributes over matrix addition. Let's see next. So here is your second property of scalar multiplication. K plus L into A is equals to K times A plus L times A. What we have here? We have two scalars K and L added together, and we have a matrix A outside. And what is happening here? This A is distributing over addition of scalars. K multiplies with A, then L multiplies with A, and there is a matrix addition in between. Note that this bracket which you see is a scalar. This A is matrix. So what is happening here? Scalar multiplication is happening. Then after that, this is a scalar, this is a matrix, this is scalar multiplication. This is a scalar, this is a matrix, this is a scalar multiplication. And there is a plus in between. This is a matrix addition because this is a matrix, this is a matrix. So matrix plus matrix, nothing but this is matrix addition. I hope these properties are clear. Let's go next. Let's move on to problem section. Problems based on whatever we learned. So I have one problem over here. Two matrices are given, A and B matrix, and there is one equation given. You all can see that. Which equation I'm talking about? This equation I'm talking about. This 3a plus 2x is equals to 4b. In this equation, you all can see there are three variables, a, x, and b, out of which a and b is nothing but the matrix which is given below, and you have to get the matrix x. This x you have to find out. So how to do that? So there are some primary steps involved which we will see since we are solving for the first time to understand why those properties are important, but we will not include those steps in the solution. Okay, but you should know the idea, how it works, how it goes. That idea has to be clear. It should not be like you are just dealing with some numbers. Here we are not dealing with just numbers, we are dealing with matrices. Okay, so let's see what are those primary steps involved in the problem. So first of all, the line number 1 which you see here is nothing but given to you. This is given to you. And what we need to do here, we have to add minus 3a on both sides. Why to add minus 3a to both sides? Because if you observe this equation, 3a plus 2x is equals to 4b, and we have to get this x. To get x, we should have x alone on the left side, and that has to be equals to something. So to get x alone, what I'm doing, I'm adding this minus 3a on both sides. Why to do that? What will happen? That you'll see next. So let's add minus 3a on both sides. So if we add minus 3 on left side, so you get minus 3a plus, and there was this term already. So I have used a bracket for that. Equals to, again minus 3a, you have to add on right side as well. Both side we have to add so that equality holds. And there was this 4b already in the right side. What next? You can concentrate on the left side. What I have done, I have replaced this bracket by a new bracket. Now instead of having bracket for second and third term, I am using bracket for first and second term. This is happening because of that associative law. What was the associative law? Your associative law was a plus b plus c is equals to a plus b plus c. Your associative law says the bracket is no more important if there is a matrix addition happening. So we have this matrix addition happening over here. So the bracket is no more important whether we use a bracket for the first two terms or the last two terms. So instead of having bracket for the last two terms, I have used bracket for the first two terms. And you are getting this LHS now. And after that, in the RHS, you can see I had this and now I have this. How can we do that? That can be done by using commutative law. What was the commutative law? Your commutative law was A plus B is equals to B plus A. Order does not matter. How we add, that doesn't matter. If there is a addition, there is a matrix addition. So whether we add this first term with the second term or we add the second term with the first term doesn't matter. And you know 4b plus minus 3a is 4b minus 3a. So I have written directly over here minus of 3a. And after that what? Let's see the LHS part. In the bracket we have minus 3a plus 3a. 3a का negative. Negative of 3a is minus 3a. So you all can remember existence of additive inverse property. A added with its negative gives you null matrix. So here 3a added to its negative gives you null matrix. So this bracket result into 0, nothing but null matrix. Then there is a plus, this plus, and there is a 2x is equals to, this remains as it is. And after that, here we apply your property number 3, existence of 0. What was that property? That property says if 0 added to any matrix or any matrix added to 0, the result, there won't be any effect on that matrix. So there won't be any effect on 2x, 2x remains 2x. And this comes as it is. So we have ultimately the 2x is equals to 4b minus 3a, and if we get the some value on the right side, what we need to do after that, we just multiply 1 by 2 on both the sides. If we multiply 1 by 2 on the both the sides, to the left side you'll get x and to the right side you'll get some matrix, and that is nothing but value of x. But we are not going to do all this every time. This is just for explanation purpose, so that you should understand what happens in the background. Practically what we do, practically we just treat this 3a plus 2x equals to 4b as a usual equation, and what we do, mentally we just shift this 3a to the other side. So if we shift this 2a to the other side, will give you 2x is equals to 4b, and if 3a goes to the other side, that will become minus 3a. This both are one and the same. But the idea has to be clear how it works actually. So to get directly this, there are lots of steps involved in the background. That idea also has to be clear. Let's come to the main solution part. The main solution part starts over here. So we had this, and practically what we do, we transfer this 3a to the other side to give you minus 3a. So we get this. And after this, we put the value of b and a. So 4 remains 4. B in place of b, we put the matrix b minus minus 3 as it is. In place of a, we put the matrix a. And after that, we perform that matrix scalar multiplication. We perform that scalar multiplication. 4 times of matrix, 3 times of matrix. And how we do that? We do it, we multiply each element by that scalar. So this matrix multiplied by scalar 4 to give you this. This matrix gets multiplied by scalar 3 to give you this. And there is a minus in between. Scalar subtraction we can do. How we do that? We do it component wise subtraction. So minus 4 minus 9 minus 13, 16 minus 0 16, like that. That will give you this. And after that, this LHS is 2x. That's not the value of x. To get value of x, we multiply 1 by 2 on both sides. So if we multiply 1 by 2 on this side, this will give you 1 by 2 into 2 is 1. So you get x, and to this side you get 1 by 2. 1 by 2 means again you perform the scalar multiplication. So each element multiplies by 1 by 2 and you get this answer. I hope the solution is clear. Let's proceed to the next problem. Here is your next problem. In this problem, we have to find the value of x and y. X and y are nothing but the matrices. I have two equations over here. Equation number 1, equation number 2, we can say. What I am going to do here, this looks very similar to our simultaneous equation. You have seen this x plus y is equals to, let's say, 2. X minus y is equals to, let's say, 3. The thing which we have here looks very similar to the simultaneous equation. And what we do there, we solve them simultaneously. So what we can do to solve this, we can see there is a plus y, there is a minus y. So if we add 2, this plus y and minus y will get cancelled, and this x will add to x to give you 2x. So 2x will be equals to this first matrix plus this second matrix. And you'll perform obviously this matrix addition. You'll get something, and after that you'll multiply by 1 by 2 on both sides to get the value of x. And you'll get the value of x. What after getting value of x? There are many ways to do that, but what I have done in my solution, I have subtracted the 2. Okay, this is one way. What will happen if we subtract? What will happen if we subtract? We have this x plus y equals to the matrix. We have this x minus y is equals to the matrix. And if we subtract, minus, and this will become plus, and this will be minus. X minus x, 0. Y plus y, you will get 2y, the matrix 1 minus the matrix 2. You will get value of 2y. After getting value of 2y, you can transfer this 2 to the other side, or nothing but you can multiply 1 by 2 on both the sides to get the value of y. This is one way. Or we can do what? After getting value of x, we can put in one of the two equation. We can either put in equation number 1. Here you can put value of x, and this x you can transfer to the other side to get the value of y. That can also be done. Let's see the solution step by step. Here is the solution. So I have given equation 1, equation 2 both, and after that I am adding them. 1 plus 2 gives, so if we add them, y and minus y gets cancelled to give you 2x, and the first matrix plus second matrix, if you add these two matrix you will get this, and that's the value of 2x. To get value of x, you have to multiply both the sides by 1 by 2. So if you multiply by 1 by 2, this matrix will be multiplied by 1 by 2, nothing but each element will be multiplied by 1 by 2, and that will give you answer, nothing but value of x. Then one way to get y is subtract. subtract 1 minus 2. Do 1 minus 2. So if we do 1 minus 2, this x minus x, so x minus x 0, plus y minus of minus y 2y. So that will give you 2y. First matrix minus second matrix. So if you perform this matrix subtraction, you'll get this. And that is the value of 2y. So to get value of y, what we have to do next? We have to multiply 1 by 2 on both the sides. So if you multiply 1 by 2 on the both the sides, you will get the answer. I hope the solution is clear. So here is your next problem. I have some equation over here and I have to get this x and y. This time this x and y which you see is not matrix. They are numbers. You can see x is what? Element of matrix. Y is what? Element of matrix. That is not matrix. That is element of matrix. Nothing but element of matrices here are nothing but the numbers. What we need to do? We have to perform this scalar multiplication. 3 into this matrix we have to perform, nothing but each element will be multiplied by 3 then. So if we multiply, you'll get 3x, 3 2s are 6, 3 3s are 9, 3 1s are 3, plus here is your second matrix that equals to your third matrix. And after that you have to perform this addition, matrix addition. So you'll perform matrix addition after that. So if you perform matrix addition, it will give you 3x plus 4, 6 minus 1 is 5, 9 minus 2 is 7, y plus 2 plus 3 is y plus 5 equals to the third matrix which you have, that is 10, 5, 7, 4. And if you compare the two matrices are equal means each element should match. So this 5 is matching with this 5, this 7 is matching with this 7. So this 3x plus 4 matches with this 10 to give you 3x plus 4 equals to 10. That gives you x is equals to 10 minus 4 is 6. Then we divide by 3 to give you 2. X value is 2. Then we match this y plus 5 with this 4. Y plus 5 equals to 4. So y is equals to minus 1. And this is how you get x and y value. Here is the solution. That same thing is done over here. I hope the problems are clear. And if you have any queries, let me know in the comment section. I have used one new thing over here in this video. I have used some GIF images. I have made those GIF images along with some color combinations so that the idea will be more clear and will go easily into the head whether you liked it or not. Let me know. Let me know in the comment section. So here is exercise for practice. These are the problems to practice. These are very much similar to the problems which I have solved in my video. So you all can understand those problem solving and you can apply those concepts over here to get the answer. Answer of this exercise I'll put in my next video. Thanks for watching and don't forget to like if you like the video, comment, share and subscribe to my channel if you haven't subscribed yet. Thanks for watching.